All right, gentlemen, welcome. Today we're going to talk about solving systems of equations using graphs. In order to receive credit on this lesson, since it's a homework assignment, I need you guys to take notes. That includes writing down the section, writing down any key terms or definitions, and definitely writing down the two examples that I'm going to do at the end. That needs to be done for next class in order to receive credit. In our last activity in class, we talked about the process of buying a car, and we talked about how the value of a car decreases over time, but our investment in the car increases over time. And what we did is we eventually found where those two lines intersected, and that told us a point where it would be a really good idea to sell the car at that time. That was basically a system of equations. Okay, so a system of equations is when you have two or more unknowns, such as x and y. Most of the time, systems of equations will look like this, where we have two equations with two variables in each, and we have this brace or bracket here showing that they go together. Our goal in this, in solving, is to find the x and y value that works in the first equation and in the second equation. So you could think of many different examples of ordered pairs, x comma y, that will work in the first, but there's only going to be, in most cases, one point that works in the first one and the second one. So guessing and checking could take you forever. So this is called a linear system because both of these equations will eventually be written in slope-intercept form and be straight lines on a graph. We're trying to find the solution of a system, which is the set of values for the variables that makes all the equations true. You can solve a system of equations graphically or by using tables. We're going to focus strictly on graphing. I think tables are sometimes a little bit more difficult. So when we talk about linear systems, I need you guys to always, again, as soon as we hear the word linear, you're thinking straight line. And a system is basically two. So what options do we have for a linear system? Well, one, we could have two lines on a graph that intersect. So this first example over here on the right shows us that we have intersecting lines. Intersecting lines have exactly one point in common. So we say that it has one solution. Our goal is to find what that one solution is. Now, two lines will always intersect if they have different slopes. So if the two equations have different m values or different slopes, they will always intersect, so we're going to be able to find that one point. You could have, and these next two examples are a little bit more rare, but you could have two lines that end up being on top of one another. All right, so this line here, they make it purple. They just kind of combine the two colors there. But they say that they're coinciding, which means on top of one another. Anytime that happens, they have infinitely many solutions, or IMS, we can shorten that, because every point that's on the line is on both lines, right? So they have an infinite amount of points in common. Now, we can tell that something has infinitely many solutions from the equation because they have to have the same slope and the same y-intercept. If they have the same slope and the same y-intercept, they're going to be the same line, which means they're coinciding, which means we're going to say that they have infinitely many solutions. The last one down here is parallel lines. You guys know parallel lines never intersect, and the reason they don't intersect is because they have the same slope. But we can't just say same slope because that would get us back to thinking about infinitely many solutions. So parallel lines, we're going to say have the same slope and a different y-intercept. So just from the equation, we can figure out which one of these three pictures we're going to see on a graph. Parallel lines never intersect, so they have no solution because there's no point that will work in both equations. All right, so for our first problem here, I'm going to walk through the steps. We want to get both of these lines on a graph. So I'm going to start with the first one, and we're kind of lucky here. I'm going to put this one in red. We're kind of lucky because both of these equations are written in slope-intercept form. So I'm going to go right down to -1 as my y-intercept, and then my slope is +1, so up 1 and to the right 1. And then I'm just going to draw a straight line through those points, and I'm going to extend this through the entire graph. Okay, so that's my first line. My second line, which I'm going to put in blue, has a y-intercept of +3 and a slope of -1. So -1 slope means down 1 and to the right 1. And I'm going to again extend a line through the entire graph. Now, we know from the equation that our slopes were different. The first one had a +1, the second one had a -1, so we know they're going to intersect. Our goal is to find the point that they intersect, which looks to be right here at 2, 1. So if 2, 1 is the intersection, that would be our solution, but we have to check that. We can't assume. So we're going to take 2, 1 and plug it into both of our equations. So I'm going to plug in 1 for y and 2 for x, and I get 1 = 1. So the first equation works. The second equation, I'm going to plug in 1 and 2 for x, and I get 1 = 1, and that works. So since my point 2, 1 works in both my original equations, that is my final solution, 2, 1. In number 2 here, they make us work a little bit because we got to get both these equations in slope-intercept form. So for the first equation, I'm going to do that one in red again. We have to subtract 2x from both sides to get y = -2x plus 4. And the second one, we have to subtract, let me switch colors here. We have to subtract x, and then we have to divide by -1 to get y completely by itself. So that's just going to switch every sign. So now we're going to get x -2. Now I'm going to graph both of those. So the first one has a y-intercept of +4, slope of -2. And I'm going to continue this. I'm going to continue to go down 2 over 1, down 2 over 1, down 2 over, all the way through my graph. And then I'm going to connect my line there. And now my second equation has a y-intercept of -2, slope of up 1 over 1, up 1 over 1. And again, my two lines intersect because they have a different slope. What I mean again by that is this number and this number are not the same, so they're not going to be coinciding or parallel. So it looks like my point is at 2, 0. Now I got to check that. Now you can check it in either the original up here or into the equation that we changed it into. So you got to check it in one of these two, and then also either this one or this one. It does not matter. Okay, so whatever one you think is a little bit easier. So for the, I'm just going to use the originals. So 2 times 2 plus 0 = 4. So 4 = 4, so that one works. And then for the second one, 2 minus 0 = 2. And I get 2 = 2, so that works as well. So that means 2, 0 is my solution. 2, 0 is the only ordered pair that will work in both of those equations. To get full credit for this video, I am going to have you guys try 2 problems on your own. On page 319 in the iBook, I want you guys to do number 7, which you guys can check your answer for, and also number 8. Both of those need to be graphed by hand with your notes from the last 2 problems, and we'll check that in class.